Okay, now for what we have in the third problem, okay, we're still looking at the use of the method of shells, and this time we're looking at taking the generation of the solid about the x-axis. And so the method of shells, we're going to integrate over the variable y. Now we have with our given functions, okay, we have the x equal to 7 and that y is equal to 4 minus x, which we're going to change over in terms of x equals. And for right now we have 4, y is equal to 4 minus x. Okay, this is going from x equal to 4 to x equal to 7. And we're going to rewrite from terms in the domain to those in the range, that is going from x equals 4 to x equals 7 to its equal, or its conversion in terms of what we have for y. And so for what we have in rewriting from y is equal to 4 minus x, okay, rewriting we had the x equal to 4 minus y, okay, and so if x were equal to 4, okay, your y value would be equal to 0, and if x were 7, we have 4 minus 7 be a negative 3, so we have for the lower limit in y, you have from negative 3 to 0, and we're going to integrate over x is equal to 4 minus y. And now in terms of what we have in looking at what is present, okay, we have from the graph, okay, in the illustration, okay, you would see that the line is over in the third quadrant. And so if we look at utilizing the method of shells, okay, at the third quadrant where y is negative, and what would normally be your 2 pi y expression, okay, it's going to be 2 pi times negative y since we are over in the third quadrant. So for what we have in terms of the volume generated about the x-axis, okay, we have is equal to negative 3 to 0, okay, which y approaches, and we have the integral of negative 2 pi times negative y, and then we have times, instead of the height as before, we have now the width. So we have the upper limit of x equal to 7, lower limits we have at 4 minus y, okay, over to the left, okay, and we have integrating over y. And so for what we have in combining the terms together, okay, we have for v of x, we have again the integral going from negative 3 to 0, negative 2 times pi times y, and again 7 minus 4, then 7 minus negative y, we have converting to 3 plus y dy. And in looking at the distribution, okay, we have working with negative 2 pi y, we come out to the product at negative 6 pi y minus 2 pi y squared dy. Again, as we had the value of y to go from negative 3 to 0, and in looking at what we have with the antiderivatives, which we attained from using the power rule of integration with respect to the variable y, we come out to this two-term expression whereupon we have negative 3 pi y squared minus 2/3 pi y cubed, as y again goes from negative 3 to 0. And so working with the substitution, upper limit renders the expression to 0, and so the volume is going to be determined upon the proper application of negative 3 for y in the lower limit. And so we have negative 27 pi plus 18 pi. Distributing the subtraction over this collection of terms, it is going to follow that the exact value of the volume generated about the x-axis with the given functions ends up at 9 pi.